QuaranSTEAM with the MarineQuest team presents Water Explorers Volume 2. Is the quarantine getting you down? Are you feeling like Penelope? We hope you can work with your family to conduct the following experiments to beat those quarantine blues. Before you begin these activities, please watch our first Water Explorers video found in the link below. Some of the information from the first video will help you to understand the concepts in this one. Let's start out with a very simple activity to stretch out those science muscles. We're going to need them later. For activity number 1, you will need a glass full of water, a mixing utensil, and blue and yellow food coloring. What color will we make when we mix in blue and yellow food coloring? Pause this video and give it a try. We get green! My favorite color. Well, I bet you already knew that would happen. What if Penelope wasn't there to mix it? Do you think we can get the water to mix itself? Let's start our second activity. For activity 2, you will need 2 glasses, one filled with cold water and the other filled with hot water. You will also need blue and yellow food coloring. To get the water nice and cold, we left it in the fridge for a few hours. The hot water was made in the microwave. Whenever working with warm or hot water, be sure to wear personal protective equipment like oven mitts. Set up both of your water glasses side by side and add a few drops of blue and yellow to each. Pause this video and carry out your experiment. Let's see if we obtain the same results. After a few moments, the hot water turned mostly green. The cold glass did not mix very much. Let's zoom in and see what's going on with those water molecules. You can see the molecules in the hot water have more energy and are therefore moving rapidly and spread farther apart. The molecules in the cold glass are less energetic, are close together, and not moving around as much. The excited warm water spreads the food coloring around much quicker than in the cold water. Remember the first Water Explorers video when we demonstrated what happens when a salt and freshwater body come together? We wanted you all to have the same opportunity to carry out these types of experiments at home. For the remainder of this video, we will be conducting a series of density experiments utilizing the following materials: a clear deep dish, plastic or paper cup, tape, binder clip, water, salt, food coloring, a mixing utensil, and a small nail. If you can't find all these items in your house, try to improvise. Instead of the binder clip, a clothespin or potato chip bag clip will get the job done. During different parts of the experiment, you might need cold water or warm water. We recommend putting a pitcher of water in the fridge for a while before starting these experiments. You can make warm water in the microwave or on the stove top when needed. Be sure to wear oven mitts whenever handling hot water. We have made a handout to help you carry out these experiments. The handout is linked below. On the first page, you'll find some helpful setup instructions. Pages 2 and 3 are the data sheet for you to make predictions about what will happen and to record your results. Not to worry if you can't print out the handout. You can simply make sketches in your notebook at home. Follow along to see how we set this up. Use a small nail to carefully poke a hole below the midpoint of the plastic cup. This cup can be reused. Now cover the hole with tape. Secure the cup inside the dish using the binder clip. This table shows all of the experimental setups for the 8 density experiments we will be doing. Experiment 1 requires salt water in the tank and fresh water in the cup. Watch as I conduct density experiment 1 and then try it out on your own. For density experiment 1, you will pour fresh water into the tank. Make sure the water level goes above the tape on the cup. Add salt to the tank water and mix thoroughly. Add fresh water to the cup and mix in food coloring. What's going to happen when we remove the tape? Use a colored pencil, crayon, or marker to color in a prediction on your data sheet. This is my prediction. Remove the tape and observe. The fresh green water went to the top. Record your results. When I filled in my data sheet, my results looked like this. We obtained these results because fresh water is less dense than salt water. A less dense solution will float on top of a denser one. Denser solutions will flow to the bottom. Okay, I think you got the hang of this. You should now use the instructions found in the Water Explorer's datasheet linked below to carry out the remaining density experiments 2 through 8. Remember, unless it specifically says cold or warm in the instructions, the water used should be room temperature. Feel free to refer back to this video along the way to compare your results to mine. Now pause the video and start exploring. That's weird. The water's not coming out. I'm going to need to use my mixing device to force the water out. Phew! After all that, what did we discover about density? What types of water are most dense? You got it! Cold and salty water are most dense and will sink to the bottom. Density is how compact something is. The more stuff you have in a space, the higher its density. For warm versus cold water, the warm water has more energy and the molecules are spread farther apart. Therefore, warm water is not as compact and is less dense than cold water. Salt water contains dissolved salt molecules, meaning there are more particles in the same volume than in pure fresh water. So salt water is more dense. So why is this important? Well, have you ever thought about how water moves in our ocean? Looking at this picture, you can see how water moves at the surface. What energy drives this surface circulation? Wind! What about motion in the remaining 90% of the ocean? How is the water in the deep ocean moving? These demonstrations will help illuminate what drives the deep water currents on our planet. This setup represents a cross-section of the ocean, with surface waters traveling across the top horizontal bar and our deep waters traveling across the bottom crossbar. Ice is added to the right square container to represent the frigid water near the poles. Warm water is added to the left square to represent the warm equatorial waters. Room temperature fresh water is added to one cylinder. Watch how both sides fill up. Just like on Earth, we have one large interconnected ocean. By adding food coloring, we can track where the water goes. Let's watch. So cool! The warm, less dense water flows across the surface, and cold, dense water flows across the deep ocean. Where the cold water meets the warm tube, you can see a river of cold water sinking down to the depths. This pushes the warm water up and across. This sinking cold water is the engine that drives the deep water circulation. Let's repeat this experiment using fresh and salt water. First, I'll fill up our ocean with fresh water. Next, I'll make a salty blue solution. Let's see what happens when I add the salty blue water. Excelsior! This salty, dense water sinks to the bottom and a deep water current is created. The less dense fresh water flows across the surface water. Once again, the sinking dense water is the engine that drives deep water circulation. Deep water currents on our planet are called thermohaline circulation. Thermo comes from the Greek word for temperature, and haline from the Greek word for salt. Where is the coldest and saltiest water on our planet formed? Where glaciers are created. As the ice forms, the salt is left behind as a frigid brine. This super dense water sinks to the bottom and creates the conveyor belt of thermohaline circulation that moves water all around our planet. Although thermohaline circulation is an extremely slow current, taking almost 1,600 years for a water droplet to make the complete trip, this density-driven current is vitally important to our planet because it circulates heat to our poles and helps maintain a constant climate on our planet. Without thermohaline circulation, our planet would be a much different place than it is now. Who knew the density of water was so important? We'd love to see how your QuaranSTEAM went. Share your results with us by tagging MarineQuest UNCW on Facebook or using the hashtags MarineQuest Water Explorers and UNCW MarineQuest. Thank you for joining us for our second Water Explorers adventure. Stay safe, everybody, and we hope to see you in person real soon.